So this is what we're going to do. You say let the square numbers be s squared, s plus 1 squared. Since the question says two consecutive, so in other words, it's like I'm saying let the numbers be x, s plus 1. But because the question specifically say they are square numbers, so s squared, s plus 1 squared. For instance, let's take value for s. For s squared to be a square number, that means s can take from 2. So if s is 2, for instance, the first number will be 2 squared, which is 4. So 4 is a square number. Substitute that same 2 into s plus 1 squared. That's 3 squared, which is 9. So 9 is a square number. Is that clear? Are you there?
Yes, sir.
Okay. Now, sum. So let's now sum those numbers now. So the sum will now be square s plus s plus 1 squared. I will now open the bracket, collect like terms where necessary. So square s plus, if you open this bracket by expansion, it gives square s plus 2s plus 1. Collect like terms where necessary. You have 2 square x plus 2x plus 1. And if you look at the first two terms, you can factor out 2. So if you factor out 2 in the first two terms, you have square x plus 1. Now, I can express this as 2n plus 1, where n is square x plus x. So I have replaced square x plus x with one entity, n. So 2n plus 1 is odd. 2n plus 1 is odd. Remember, go and check those facts that I gave you. We said any odd number can be written in that form, 2n plus 1 or 2n minus 1. Is that clear? So
Yes,
since
sir.
we have been able to get 2n plus 1, which is odd, so we can now conclude. Hence, sum of two square numbers is always odd. So anytime you see question of such, this is how the thinking will go.
Yes,
Am I communicating?
yes, sir.
So please write. So when you are done, let me know. When you are through, let me know, please.
I'm through, sir.
Okay. Now, before we proceed, I want to give a remark here. Look at the term that I've circled here. If you make your conclusion even from here, you are good to go. In the sense that this will always satisfy that condition. Now, remember we have said from here that the square numbers are s squared, s plus 1 square, and so on. And when we wanted to test, we started with 2, s equals 2. S equals 2 gives us 4 here, and here 9. You may want to ask me, can't x take 1? Yes, x can take 1. If n is 1, x is 1, for instance, that means the first number here will be 1 squared, and the next number here will be 2 squared. 1 square is 1, 2 square is 4. 1 is also a square number because square root of 1 is 1. Am I communicating? Now, let's substitute 1 for x here in this circle, this purple circle here. If you substitute 1 for x, let's now evaluate it and see if we are going to get odd number. So substitute 1 here. So you have 2 into 1 squared plus 1 plus 1. And that gives 2 into 2 plus 1, which is going to be 5, which is odd. If x takes 2, substitute 2 for x here, we are going to have 2 into squared plus 2 and plus 1. And that gives 2 into 4 plus 2, 6, plus 1, which will give you 13, which is also what? Odd. Can you see that now? So if you carry out your test here from here, and you conclude from here that n, the sum of two square numbers, is always odd, you are good to go. But it will be compact, it will be neat if you represent square s plus x as one entity. So reason for doing this. Does that make sense to you?
Yes, sir.
Okay. So let's move on. But this time, let's, okay, let me see. I want you to try this. I want you to attempt this. This one says, prove that the difference between 8 raised to power 12 and 12 raised to power 7 is a multiple of 4. Prove that the difference between 8 raised to power of 12 and 12 raised to the power of 7 is a multiple of 4. I want you to attempt that. Very good. What you don't think. Are you making progress?
Yes, sir.
Okay.
So am I allowed the calculator in this exam?
For this type of question,
Yeah.
you don't need calculator for this type.
What do you mean? Oh, out of the proof you gave me, there's none that applies to this.
It's not what?
Out of the proofs you gave me, there's none that really applies for this. I don't even know what to start.
You don't know what to do.
Yeah.
Okay. But what's the keyword there? The keyword is difference, right?
Yeah.
Another keyword is multiple of 4. Now, when you are asked to show that is a multiple of a particular number, you must be able to factor out that number. That's what it means. Now, let's do it together. Now, you were told that the difference between 8 raised to the power of 12 and 12 raised to the power of 7 is a multiple. Now, between 8 raised to the power of 12 and 12 raised to the power of 7, which one do you think will be greater? But of course, it doesn't matter, since we want to show that it's a multiple of something. It doesn't matter which one you are writing first. But as you have asked that, can you use calculator for this? You may want to see which one is greater between 12 raised to the power of 7 and 12 raised to the power of 12. I mean, 8 raised to the power of 12. You may want to check in order to know which one you are subtracting from which one. But that does not really matter. Am I communicating?
Yes, sir.
Okay. So since we are trying to show that is a multiple of one another, so I can say that 8 raised to the power of 12 minus, I'm using the keyword difference now, 12 raised to the power of 7. Now, in this context, I will now apply my knowledge of indices. What's the knowledge of indices I'm going to apply? I will break 8 raised to the power 12 to 2. And I'll also break 12 raised to the power 7 also into 2 by saying 8 times 8 raised to the power 11. Remember, from first law of indices, I can have this 8 raised to the power 12 to become 8 times 8 raised to the power 11. Isn't it? Do you agree with that?
Yes, sir.
Okay. Minus, I'll do the same thing for 12. 12 raised to the power 1. Okay, let me put 1 here so that it will be obvious. Times 12 raised to the power 6. By first law of indices, I'll go back to 12 raised to the power of 7. Now, when you are proving, you must not lose your guard. You must be conscious of where you are going. Now, where we are going is we want to show that it's a multiple of 4. 8 raised to power 1, I can write it as 4 times 2. Do you agree with that? Similarly, I can write 12 raised to power 1 as 4 times 3. Hope I'm communicating.
Yes, sir.
So if you look at the entities now, you can see that I can factor out 4. So if I factor out 4, I'm going to have 2 times 8 raised to the power of 11 minus 3 times 12 raised to the power of 6. So you can see that I've been able to factor out 4. So because I've been able to factor out 4, that means the difference can actually be expressed as multiple of 4. So we now conclude. This is multiple of 4. So you now conclude that hence, now it's important you make your conclusion. It's very, very important. Hence, the difference is a multiple of 4. Hope that makes sense now. So please write. And when you are through writing, let me know. Hope you are writing. Hello, Ade.
Sir?
So when you are
I'm
through
not.
writing, let me know.
Okay. I'm done.
Okay. I want you to try another one. This one says that given that 2x plus a equals 7 into x minus 2a minus 5. Prove that if a is odd, Then X is even. If A is odd, then X is even. So write the question and attempt that. Are you making progress?
Yes, sir.
How far are you making progress?
Yes, sir, I'm almost done.
Okay. I can let A equals 2n plus 1. Do you agree with that? From
Yes, sir.
from the fact that we have looked at, so 2n plus 1 is even. So it means that x equals 3 into 2n plus 1 plus 1. And that gives 6n plus 3 plus 1, which is 6n plus 4. And if you look at the right-hand side, I can factor out 2, and that gives me 3n plus 2. So I have a multiple of 2. So any multiple of 2 is going to be even number. Don't forget the question say if A is odd, then you must show that X is even. So we have assumed this to be the odd number, and we are able to get a multiple of 2. That means it's going to be even. Don't forget, multiply 2 with any number. The outcome is going to be even number. 2 times 3. 3 is odd. 2 times 3 gives 6. Take another odd number, 5. 2 times 5, 10, which is also divisible by 2. Take another number, another odd number, maybe 7. 2 times 7, 14. Do you understand that now? So since it's a multiple of 2, then x is odd. So you now conclude that since x is a multiple of 2, then s is even when a is odd. Is that clear? Hello?
Yes, sir.
So please add this to what you have written down. So when I don't, let me know.
I'm done.
All right, thank you. So we have less than 3 minutes. So let me end it, then you rejoin immediately.